row though?
Because that's the.
Alright, hey, okay, real quick.
This happened to be that way.
Hey, real quick. Last Friday,
Was
hey,
fine.
Friday and Thursday, we talked about the properties of logarithms. Power rule, quotient rule, product rule, all that good stuff. Goal today, I want to do a couple examples right away of what you guys did, but we're going to jump right in the deep end. We're going to start with those kind of difficult ones we ended on Friday with, because I think everyone was kind of on the same page. So let's start with kind of an easier one here. One of the problems I want to talk about was when they have multiplication and division all in one problem. So log base 4 of x to the 4th square root of y over z to the 3rd. Okay, so this is a problem that we had last week. It was kind of like the last one we did. It's using a combination of everything. Power rule, product, quotient. When I start my problem, hey,
I wasn't talking this time.
so when we start this problem, I always break up the long division, or break up the division part first. So this is the start, that I would subtract the two logarithms together. That's how it would start, thank you. Okay? Alright, now, again, why we're allowed to do this, this is the quotient rule. When they're dividing items, you actually subtract the powers. Okay? Then, next step, once you have that, I'm going to break up the multiplication rule, the product rule. Okay, shh, let's stop talking. So, when we have the product rule, we separate into their own powers and we add them together. So, or their own logarithms, I should say, not powers, but logarithms. Then the back, this part I don't really touch, I'm just going to leave it alone. The goal today is, my next example after this, is there was one problem I hinted at that I want to cover. What happens when there's multiple items on the bottom? That's what we're going to look at, so we're going to have to distribute and all that. Then the last stuff here that we have to do is, now that we're expanding these, is to drop those powers out front, because this is x to the 4. This part right here, when they have a radical, the radical itself is a square root, has a power 2. Well, this thing is just a power of half. That's what a radical is. You can always make it a fraction for a power. And whatever type of root it is, that's the bottom number. So if it's a third root, it's 1/3. If it's a fourth root, it's 1/4. But again, what we're allowed to do is drop the powers up front. So your final answer on this one would be this. Unless at any point you could evaluate any of these logarithms. Because what I mean by evaluate is maybe one of them has like a number in it that you can actually evaluate it. I think we did one of those on Friday where we had a couple that you had to evaluate as you went. That was like the first couple that we did. But that's your final answer. That is what we call expanded form for a logarithm, but it's using all the properties to get me there. Questions, comments, concerns about it?
How was your weekend?
It was good. How was prom?
Sucked.
I'm sleepy
Yeah,
now.
I kind of did it.
The songs were terrible, it was bad dance.
It was 15 hours and I got back and 6 other games on these.
Post prom good though?
No.
It was okay.
It was awesome.
It was
The whole thing was my
crazy.
favorite thing ever.
Oh my, that was fun.
Oh
Okay.
yeah, I caught my face on that.
Alright, are we good?
True news.
Yeah, let's go.
Let's talk about prom.
Now, alright, here we
You
go.
know how
We
prom
need
You
to
did
talk
a
about
good job
that.
announcing my name. You said,
You said my mom's name, bro.
Golden
Yeah.
Darla? You screwed me up so bad.
It was actually, well, problem was the paperwork had, I think, yours in particular, yours had your parents before your name.
Yeah,
It was really
because
messed
you
up.
said,
So, yeah, it was really
So
weird.
this is still Kramer.
Yeah, so I just kind of went on. Alright, there we go. Alright,
Who
logarithm.
is? Who has Holden Larson as a son or something?
64 x to the 3rd, y, z to the 2nd. Yeah, there was some mess. No,
You had so much to say though, were you tired of talking?
I was tired by the middle of it.
I know, 'cause
Why did they
you had to
make
say
you
a
do
lot
it?
for
They don't
every
have
single
choice.
person.
I was tired after saying that whole big floor group at the beginning.
I'm sure that they'll find somebody else next.
Are you
So,
retiring?
You did it last year.
So they asked whoever they want. So, all right. On this one's different than the last one we did because if you notice, we have the product rule on the bottom as well. This problem requires that you have to expand the bottom out even further. So when we actually have this problem here, you're going to separate the top and bottom. So 64x to the 3rd. We're going to subtract the bottom. Okay, like that. Now, if if the top and bottom actually have multiple items like this one does, then you're allowed to separate these as much as possible like we did earlier, but this is the part that people are gonna get wrong for the most part. This is what I've noticed from previous years. That even though they're on the bottom, there's still multiple items. You can separate them and you would still have that item on the bottom, but you're gonna subtract all the pieces, which I know seems a little goofy. I'll explain why the numbers work. Question?
Why is this time moving to the middle school?
We don't know. They won't tell us till the last
But it's
day.
not you for sure though.
So, I don't know. Seriously, it's any one of us three.
What?
So,
So,
How much you
no,
got?
we'll talk about it later. Not gonna talk about it now. Okay.
Will you,
So it's a 50-50 shot.
Okay.
would you teach stats? Have you ever taught stats?
No, I have no. So, alright, here we go. Log. Hey, log base 8, 64 plus log base 8, x to the third. Alright, so that's the top part.
Cut the 3 out.
So that's just the front, because this was on the top, so they're being added. But since the bottom and the back,
Log 8
log base 8 y, log base
z squared.
8 z squared. Now the problem is, this part needs to be in parentheses, because the idea is that both items are on the bottom and they're being multiplied. You have to have the plus in between them technically because they are being multiplied together. But here's my little shortcut. Anytime you have multiple items on the bottom, this is my little shortcut I've kind of used, because it's just easier to think about this. If they're ever on the bottom, there's multiple items. You're just allowed to just put all of them being subtracted because you're going to distribute the negative sign anyways through that parenthesis. So if there's multiple items on the bottom, just make sure you're subtracting all of whatever's on the bottom. Then you could drop the powers out front like before. So this would become a 3 log to the 8, 3 log base 8 of x. This item out front is actually a number. It's just 2 because you're trying to figure out what power you put on 8 to make 64 is 2. Then you have the log base 8 of y, and the 2 drops out front, so it's log base 8 of z. Boom. There you
Are you
go.
getting homework today?
Yes.
Oh.
Okay. Questions, comments, concerns about that one?
No.
All right. Not for a couple weeks, maybe.
Serious?
It's one of the last tests that the seniors take.
That's so long.
Yeah. We have a couple more sections to go.
Oh, okay.
So.
are we taking a test over this, Charlie?
No test over chapter 3.
Just like there wasn't test over chapter 5.
Right.
All right. Questions. Okay, moving on. All right. Last major problem that I want to talk about before we get to the new stuff today. All right, and I'm just gonna go through one of these just so you can see this. Log base 3 square root x y to the 5th. All right. Hey. All right. This is my last problem. I'd like you to take a look at. In fact, let me change this. I'm gonna change the x.
That's a half power.
Let's make that a 9. That way we get some practice with numbers and variables.
That's equal to
All right.
half power.
Yeah, so on this one, it's everything in the inside is actually under the radical. So you're absolutely correct. One of the first things I always tell people is change it to like a power. That way we kind of know how this works. So on this particular problem, I'm going to change this to be 1 logarithm so far, but 9y to the 5th, this is all to the half power. So on this particular problem, you're allowed to drop the power out front first before you can start. Don't try to separate it yet, because that half needs to drop out front. That way you get just the logarithm by itself with the items being multiplied on the inside. Okay, now that we have that, now you're allowed to take this back item and separate it.
And add them together.
Yeah, and so this will be half, and then in the back, these are all in what, I'm gonna put a bracket, even though you can just do it with a parenthesis, that everything will be multiplied by half because the half dropped out front of the entire thing. So when you separate this logarithm, it's everything on the inside is being multiplied by half because both of them have the radical on it. Because technically, one way you could think of this problem is you could think of it like this. That it could be log of that, log of y to the 5th. So each one would have its own half. So that's why you have that parenthesis there. But it's log base 3 of 9 plus log base 3 of y to the 5th. So you're allowed to separate, because these are being multiplied, so you're allowed to separate into plus. And then we get to this, and you can distribute over, you can drop powers down. When you distribute over, you get half times this logarithm plus half times this logarithm. Because the half goes to each one. Now, the weird part is that this one right here is an actual number.
That's good.
So, yeah, so, but again, let me just write this down so you can see this. This is a log base 3 of y to the 5th. All right.
Does the y drop out to the half and
When the
then?
base.
Yeah, so the 5 will drop out, yep. So this 5 will drop out front with the half. This is just a number. So if we're actually doing the math here, this will turn out to be half times 2, because that log base 3 of 9 is 2. Then this part, when I take the 5 out front, that'll be 5 halves
That's goofy.
log base 3 of y. Because the 5 will drop out front and we multiply 5 on a half, which is 5 halves.
Ooh.
And that's and you're almost done. I mean, the last thing you can do there is just make this the number 1, and you're good. Then you can keep going,
You
because
write that
half
as
times 2.
2.5 instead of 5 halves.
I prefer just leave it a mix, leave it improper.
That's not a mixed number.
All right, questions, comments?
Would you take points off if we did a half times 2, or should we like absolutely evaluate it down?
No, I'd say if you get to that point.
Piece back.
So you're showing me that you know what you're doing. All right, now.
That is incredible, Mr.
There's one problem, I'm just gonna put up on the board, just make sure you don't make a simple mistake. I'm not gonna go through it, you don't even have to write down, you can just kind of walk. It's one where, it's just a subtlety where I could definitely see people getting it wrong because they won't see how to do it. This is just something, you don't need to write it, just kind of watch as I go through this problem. And then we'll get to the last type of problem today, the new stuff that I wanna cover. All right, so this is one of the problems that I saw in the book, and I don't think I assigned any, but it's just something that I want you to know. This, let's make that a number where we can see what it is. So let's go with like 8. I wanna make sure that it's clear to see that it's a number. All right. Whatever that is, the top is being added together, right? When you
Correct.
separate this problem down and you try to separate it into its own logarithms, the top, okay, this is the top, so log x plus 8 minus log of y. And again, those logarithms are base 10, so they don't have the 10s written in there. But that's it. You can't actually go any further. This part doesn't expand out
Oh, yeah.
because they're not being multiplied and they're not being divided and there's no powers on it. I could definitely see some people making that simple mistake where they try to make them to their own addition logarithm. Or they try to like multiply them together, I don't know. It's just, those can't be separated because it doesn't look like this, where they're being multiplied. Those are being added. We don't have a rule for the addition part of that. There's not a rule for that. So that part, just, you leave it alone. I want to stress that. It was just something that I don't think we had any, up till this point, I didn't have any examples of it. But I didn't want you to make that silly mistake, like that's the final answer to that problem. You can't really go any further. All right,
Triangle around.
are we good with,
Everything? Yes.
yeah, that part. All right, brand new problem today. This is my last example that I want to cover. Last example.
It's a tornado, Justin.
There's a tornado?
Yeah, I'll make one of my own.
All right, hey. All right, last example. I'm gonna pull this one right out of the book.
If you have ice disrupting the flow.
All right, here we go.
They look black.
Guys, I'll touch down a little bit.
What number is this?
66 out of your book.
6,
Are you
6.
ready done?
What base
Log
drops out?
base 4 of x times log
Ours didn't change a base 4
Are you taking notes on this? Are we gonna have to put it back into what it is if it's on?
Gravity equals 9.8 meters per second squared.
All right. Okay. All right.
Write it down.
I'll take a picture at the end. Okay.
All right.
Well, this is weird.
Holy tornado.
All right.
You said
Okay,
number
so
66.
this particular problem, this number 66 out of the book, it was one where they gave me this. This is totally expanded out as far as you can go. The goal was to get it down to the original logarithm, a single logarithm where the leading coefficient, the leading number out front is a 1. So anytime that there's powers, you can put them back up top. So it's like doing the last problems, but going backwards. So like on this particular problem, this 1/3 will go back eventually on the top of this power, but we have to get this down to a single logarithm. So this part right here is a log base 4 of x divided by y.
Cube root.
And yeah, you're absolutely right. That this 1/3 will eventually go back up top and become its 1/3, right? So it's log base 4, x to the y, and that part will go on the actual power here, and that's, you're absolutely right, it is a cube root.
You're right.
And it's a cube root of the entire thing there. So this part here is log base 4 of the cube root of x divided by y. Now that's just this front part. We still have this log in the back that we can still do the same rules. You can put the power of 2 up top because that is its own logarithm. And this is kind of mixing the problem I just talked about. That you can put the 2 up top. And now what does it mean to have a plus sign in
Multiplication.
between? Yeah.
To add them together.
So no. So all right.
Multiplication, actually.
Yeah, it means multiplication. If they're their own single logarithms, and they're being added like this, and they have the same bases, you're allowed to go back to one single logarithm. So log base 4, and then these items would actually be multiplied together. Because when you separate logarithms and they're being added, that means they're being multiplied. So really, this is what we have. We have a radical x divided by y, and it's being multiplied on an x plus 1 squared. That's your final answer. This whole thing is the logarithm that we have. Now, if you want to put a bracket around it, it's fine. If you don't, I'll understand what you're writing there. But you're going down to a single logarithm using all the rules we've talked about. So, and it was just I was trying to mix everything together that we talked about. But question?
Why is there a pig on your wall?
I don't know. Somebody put a picture up there. I thought it was fun.
Wait, so we are welcome to just draw pictures?
No,
and put
that
them
was
up there?
that was definitely Destiny Princess, was it not?
Yeah.
So we're
She's put
welcome
up
to.
there.
Yeah.
I don't even know what it is.
Oh, that's annoying.
Okay. All right. Homework today?
What?
Question?
Erase this for you.
No. Go sit.
I'll go.
All
right. Okay. Homework. Here we go. Homework is due Wednesday this week. Wednesday. All right. Here we go. Wednesday. Page.
We have jobs, we don't have that much time.
Page
This is an awful.
421. Numbers. Okay. 421. It's going to be now. Pay attention to the numbers here.
Okay.
11 through 32. I want you to do the column down. I think there's the column on that one. I think there's 6 problems in that column. Just go. It's like 11. 15, 19, like there's like certain numbers there. Just go down. Then you're doing number 38. Then jumping to 52 through 62, the evens, which is basically a column again. And then 67 through 70.
Odds.
So, okay. There's your problems. It looks big and menacing. It's really not. It's taking logarithms, expanding it. There's only a rare case where you have to actually use a calculator where it's like that log base 3 of 9. But these are your numbers. This is due Wednesday. Stop, you're creeping me out. I'm walking away.
Just,
All right.
Right, face.